All right. So I guess we can slowly begin today's stream. So let's begin by recapping what we did during the previous stream. So I'll fire the app up. Let's wait for it to launch. So this is what we made on the previous stream, and I'll open the logs to show you. So as you can see, the app displays some notes. Here are the notes as an array, and as you can see in the logs, you can see that it subscribes to MIDI messages, because I actually have a MIDI keyboard hooked up to my computer. And what happens if I play, here we have the A4 note. If I play A4, it gets highlighted. Then if I play D, E, F, as you can see, it advances the nodes and generates some new ones. Actually, it doesn't generate them yet. These are hard-coded. So basically, what we're making is an app to help me learn how to play keyboard, because I have no idea how to do that. And so I figure out, why not just make me kind of type random notes, so that I learn how to, first of all, read the notes quickly, because this is going away. We're gonna only have notes in the final version. And then how to find them quickly on the keyboard. So this is gonna help me when learning to play. And for example, when I'm playing with someone, they can say stuff like, and now play C, or now play B. And thanks to my app, I will know where that is exactly. So yeah, all that we have is this hard-coded string of notes, which is then replaced once I enter it, once I play it, with another hard-coded string of notes. And what I would like to work on today is to actually, instead of showing the user the hard-coded notes, I want to actually randomly generate the notes. But I don't want to be going all over the keyboard with my hands all the time, because that's not really a realistic way to teach piano, because no song, I mean, probably some do, but usually this is not the case, where you have to randomly jump from one end of the keyboard to the other. So we want to do the random generation a little bit more intelligently, so that the notes are a little bit closer together. And then I want to implement counting mistakes, so that we can see how accurate we are. So first we're gonna count the mistakes to have something to work with. And then we're gonna use that information to somehow calculate our accuracy over the last some arbitrary number of notes. And basically what I want here is to have like a percentage of, like, for example, over the last 100 notes, how many of them I pressed correctly. So yeah, so we're gonna have to count mistakes and count the notes and see where that gets us. And then, besides counting errors, we probably want to add some positive feedback, because it's better to motivate people using positive feedback than negative, because if I get negative feedback, I would just Why would I keep doing something that makes me unhappy? So we'll probably figure something out to have a form of positive feedback. Because yeah, I mean this is with a question mark, because in the final version I would like to have an actual set of rules, a function in the mathematical sense that calculates some kind of experience points or something based on how well you are playing. But this would require a lot of tweaking, because we want to know which statistics we want to include in the final score, and how important each of these stats are. So right now we're only gonna add something simple, like for example a combo counter, so how many notes you have been able to play correctly without any mistakes, like in series. Yeah, so this is what we'll be working on today. And to recap how the code is structured, this is a React app. So the main component is app. It uses the use MIDI event. The code is all available on my GitHub, which is there's a link in the description. Basically it uses a use MIDI event hook that I wrote, which just gets me the keys that I press on the keyboard in real time. Then after a key is pressed, I dispatch an event to this reducer which handles the state. Let me make it a little bit bigger. So as you can see here, we have the state, which use the reducer. Into play we store which notes is the user is supposed to play, and position is like at which point in this sequence the user is. So after they played the A, they're gonna have position 1 because they're supposed to play D4 now. So the second element, therefore first index. So this is like the index of the node the user is supposed to be playing. And here we have some logging, and in case the action, this is the only action in type for now. If this is key down, so a key on the keyboard was pressed, we see based on the position and the sequence that the user is supposed to be playing, we see which note is expected. If the user pressed a note that was not the one we expected, we log the error and return the state unchanged. However, if the note was correct, we advance the position. So yeah, we advance the position. But if this is the last note, so as we can see, we are checking whether we are getting out of bounds with this array here. So if this was the last note, we change the sequence of notes the user is supposed to play to another one, which is also hard-coded, and today we will be changing that. So yes. And we reset the position, of course, because we're going back to the beginning of the sequence. Okay, so first thing to do is we want to have a way to generate random notes. So if you look, this is all in the GitHub repo, which is linked in the description. And if you look through the MIDI.js file, we have the following function. This is MIDI to name, which basically what it does is converts notes in the MIDI format, which is basically the number. Basically, all notes on the MIDI keyboard, all the keys are numbered, and this converts the number to a human readable note. So let's see if we can find a table and to show you an example. Yeah, this is perfect. This is the table we're looking for. So, for example, let's go with the C4. C4 is 60. So if we type 60 here, we're gonna get C4. If we call it with 61, we're of course gonna get the next key, which is C#4. And this is the black key. And this is how it works. And name to MIDI is the reverse. So name to MIDI of C4 is gonna return 60. And so why am I telling you this? Because if we have a way to convert the names of the nodes to numbers and numbers to names, we can just generate a random number and convert it to a node. So let's have a function called generate random, or let's just call it random node. This will, for now, this will return a totally random node just to have something to start with. And let's see the range. So A0, so we have to get our, let's say range. So I want to have it here so that I know what we're working with. So we see the first key is 21. Actually, most of the keyboards don't have one. So let's actually do something to do. So yeah, my keyboard does not have the A0. It begins with with C2. So we want to start with 36, which is C2. And then it ends on, let me see, C2, C3, C4, C5, and C6, C, D, E, oh, actually it's C7. Yes, all right. So C7 is, hang on, I lost it. Oh, okay, right there. So it's 96, and let's actually check. Yeah, it's around 60. It's supposed to have 61 keys, so it's probably correct. Alright, so now that we have the range, let's figure out how to do this in JavaScript. Because I never remember how to do that in all of the languages. I know how to do this in Python off the top of my head because there's run range. Random number from range Python, but this is basically the life of a programmer. Oh, not Python, sorry. This is basically the life of a programmer googling basic stuff. So yeah, this returns number between 0 and 1. Oh yeah, this is what we want. I mean, I know about math random and I could figure this out myself, but why bother doing that and risking making a mistake which could result in, for example, the end of the range never being reached? If we can just check the documentation. The Mozilla developer documentation is really great. So why not use the resources we have? Yeah, so this should generate the node number, but we actually want to use the node name because that's what we're using here in the state. So let's go back to the function, and we're gonna have to import a node MIDI to name, the MIDI to name function, and let's do MIDI to name node number. And to check this, we're gonna just show this random node on each render. It's not a number. Sure, of course. And now we will have to figure out why. So let's add some logging. Let's see what is the output of the... Oh, of course, as you can see, we have a floating point number, which is not what we want. Yeah. Well, this is definitely not what we want. Therefore, we will have to adjust because we want to get... There are no AF keys. So what we want to do is use this one, but we have to note that it is never equal to max in this case. So when we use this implementation, so we have to add 1 to max so that we can reach 96. And then we're just gonna copy this here. Yeah, so basically what it does, it just generates a random number from 0 to 1. Then it scales it to the amount of numbers possible and then shifts it up, of course. Yeah, so now we should have an integer. And as you can see, we have a random node generator. So now we can generate random stuff, I guess, which will be consisting of 4 nodes, or let's just call it random nodes plural. And here we're just gonna return, for now, for random nodes. And what's wrong here? Where? What do you mean? Ah, a typo. And let's see, just to check, we get 4 nodes. Let's maybe do it like this. Yep, works perfectly. So now, instead of having it here, we can use it as the initial state of the app. And we can see this is not very nice because we are getting out of range here. What we could do is increase the height of the music element which displays the notes. And actually we would have to change the position of this. This is not implemented yet. Okay, so to make it fit, we have to be able to change the min and max. So let's add, instead of this, let's have arguments that tell us which node is which range of nodes we want to use. And now, so yeah, we want the number instead of a node, and we want to have So we want this function to take in as arguments the nodes described in the human readable form because it's easier to use that way. But for the random generation, we need to convert it to the MIDI number. So we have to import name to MIDI. And let's do this. So the maximum will be name to MIDI max node plus 1. Of course, it errors out because we don't have, we haven't finished yet. Yeah, so now we have, oh, okay, yes, so we don't, so now that we added the random node generation, we added the parameters, we have to specify them in here. Yeah, so let's start with, for example, C3. Actually, let's go with C4 for now, and let's end on C5. And let's see what else is wrong here. We haven't passed the arguments here, so let's quickly do that. Because yeah, we're not calling random node, we're calling random nodes. So let's extend that to have this here. And we're gonna quickly just pass those arguments right here. And there we go. So this is perfect. We can generate some sequences and let's try playing them. This will, I don't know how to do that yet. So this is CD. So this is gonna be A4. No, this is. And now this and this is G, I think, CDF. Yes, great. So as you can see, it advanced us to the hard-coded version that we had here. So yeah, so when we reach the end of the sequence, we set the nodes to be played to be this hard-coded sequence. Let's replace that with generate nodes, or actually random nodes, and again C4, C5. And now if you play this C, oh, this is wrong C, 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 B, it works, it generates random nodes. So this is already something nice that is actually playable. So later we might want to, because right now it only covers this one octave, we might want to extend it to be able to generate nodes from other octaves, but we will have to make this renderer of the nodes able to display those high and low nodes, because right now it just cuts them off because it has a predefined height, so we'll have to fix that. And another thing I would like to do is, like when the user, the player, is just beginning, to skip the sharp notes and like start with a small range of notes, and as they get better and more accurate, increase the range. But to do that, we need access to statistics on the user's accuracy to know when to advance them to the next level. Therefore, we will now try to implement the accuracy statistics. So for that, we will first begin with counting mistakes. So of course we want to have some place to display how many mistakes were made. So let's jump to this HTML code, actually JSX. Let's do a paragraph and say mistakes were made. And here we want to have the count of the mistakes, so we have to store it in the state. So in this initial state we also add mistakes 0. And now we can display the actual state. Mistake 0, okay. So now every time we make a mistake we need to increment this, so we go to the reducer. Here we find this check. So as you can see here we log that this is the wrong node and just return the state unchanged. Instead, what we can do is extend the state with, modify it with mistakes. This is how it was called. Yes, mistakes. And this is gonna be, so as a reminder, this syntax basically generates an object that is identical to state, with the exception of everything that comes after this part. So it replaces mistakes with mistakes +1, and this state argument contains the current state before the changes, so we can use it to generate the next state based on the last one. And if we did this, this should already work. Let's press the wrong key, and there we go, we can count mistakes. And let's just verify that if we press the correct key, I don't know if it did, I didn't look. If we press the correct key, does the counter get incremented? No, so everything works perfectly. And I would actually like to change, this is unrelated, but I want to change the color of this, of the highlighted nodes to the blue, because this red seems like, looks like a mistake. So I'll just quickly do that. Blue, there is no such color. Wonderful. And this is a little bit hard to see. Let's try just green. Yeah, this is perfect. Yeah, so let's try playing B. Wonderful. And then it's, yeah, great. So now we have an absolute count of mistakes, but that's not really useful. So what we want to do now is see how many mistakes we did in the last 100 key presses. So to do this, my first idea was to, instead of having an absolute count of mistakes, have something like last 100, let's call it outcomes. And this would be a list where an outcome could be either 0 or 1. So if we press the right key, we're gonna have 1. If we press the wrong key, we're gonna have the, if we press the right key, we're gonna get 0 in here. If we press the incorrect key, we're gonna have 0. And then we will be able to see, we're gonna keep appending to this list, and then if we reach 100 elements, we're just gonna have to trim it to keep it at most at 100 elements. And then to calculate the accuracy, we're gonna get the sum of the correct we're gonna sum the elements. So this will be the number of correctly entered notes. And then we just divide by 100 or by the length of this to get the percentage of accuracy. So let's start. This will be empty at first because this is unknown yet. And let's have an function called, actually maybe first let's get the data in here. So what we have to do, now we have this in the state. So in case, again, if this is a wrong note, if a wrong note was played, we're gonna have to the last 100 outcomes array, we're gonna have to add. So we want to keep everything that was in the last 100 outcomes array in the list. And then at the end, we want to add 0, because this is how we mark an error. And besides that, we want to keep it to 100 items. So I would have to see exactly how slice function works, because arrays in JavaScript have a slice function which should take the take the index of the first element and then an amount. Okay, and it does not modify the original array, which is perfect. So we want to take the last 100, or actually, to keep it simple, because it's easy to take the first 100, because you just type 0, 100 and you get the first 100 elements. But if you want to take the last 100 elements, you would have to do some math. So in case we would have, if we had an array with, I don't know, so let's, for example, we have an array with 12 elements. To get the last 10, we would have to start with 2 and take 10, probably, or actually start with 1 and take 10. Something like this. Yeah, okay. I actually did it wrong. I forgot about 10 and 11, lol. Okay, yeah, so we would have to start at the second element and... sorry. Yeah, never mind that actually. So basically we'd have to do some math to figure out which element we have to start and how many to get. And if we just want to use the, for example, get first 10 elements, we just type 0, 10, and we get the first 10 elements no matter what. So let's do it like this, and then we can call slice. Sorry, I got a little bit. I started rambling, but now we're back on track. So we take the first 100 elements. So in case this is shorter than the 100 elements, it does not matter, because it will just take as many as it can. But if it's over 100, then it will start cutting it. And now we want to do the same thing for in case we press the correct note. So actually, let's first do it in the simple way, but then we'll fix it to make it nicer. So yeah, we want to do this, but instead of 0, we're gonna enter 1 in case we have the correct note. And the same thing we will have here. And now, as you can see, we have the same thing twice. So instead of doing that, we can have const new outcomes or something like that. keep it there. And actually, there's another trick I want to show you. But first, let's do it the simple way. So basically, we change this into a variable so we can use it twice. And now, actually, if we name this variable last 100 outcomes, we don't have to have this. We can use a shorthand. So we just have to type the name and it will automatically, JavaScript will understand what we mean and do it right. Okay, and now let's see if it works. Let's press our wrong note and we have an outcome of 0. Now this is C#, I believe, yes. So let's play C# and there we go, we get 1. And now let's quickly play 100 incorrect notes. So that we have something, we can see if the cutting works. And now I'll press the right note. And the length of this should not change because we should have only 100 elements. So let's try, let's see, this is C# again, so let's press C#. And as you can see, this end of this hasn't moved except a little bit because 1 is shorter than 0. So yeah, so if we press another incorrect note, as we can see, the 1 moves. And after 100 mistakes, another 100 mistakes, this 1 should, as you can see here, get removed from the list. So this way we can keep track of the last 100 key presses and therefore calculate the accuracy of the user over the last 100 outcomes. So let's have a function to do that. Accuracy, and let's actually pass it we're gonna pass it the last 100 outcomes as the parameter, and let's actually have a num argument which with the default value of 100, which will describe over how many nodes we want to do this. So we may want to also show the accuracy for last 10 nodes, last 50 nodes, so we will be able to do that. So the first thing we want to do, the main case, is basically we want to calculate the sum. So now we have to check, is there reduce, or is there sum, or is there total? Okay, so we will have to implement the sum. So we're gonna do it in a nice functional way. So we're gonna use reduce. And let me, I guess, show you how reduce works and remind myself. So let's say we have an array like this, and we want to sum all the numbers. So reduce takes 2 arguments, actually 1 argument, and it is called on the array. And basically it takes a function that takes 2 arguments. And it tells us what to do with those arguments. And as we can see, it works. And now, what does reduce do actually? So what it does, it takes an array. Let's say, for example, 1, 0, 2, 4, 5. This is our array that we will be working with. And if we call reduce, it has a function. So let's call it f, and let's do it a plus b. This can be anything else, but I'll just use that to demonstrate how it works. So basically, what reduce does, it thinks, okay, the first 2 elements are 1 and 0. So let's call the function on the first 2 elements. We get 1. And now let's reduce the array. So let's make it shorter, basically, by replacing those 2 elements that were there before with the with the result of that function. So this will be now 1, 2, 4, 5. And this is repeated until the array has only one element. So now the first two elements is 1 and 2. So this gets us 3. So we replace this 1 and 2 with 3, the result of the function f, which is a 3, 4, 5. And then we can call that function again, because we still have some elements left to compute. So this gets us 7. So we replace the first two elements with 7. And we are left with 2 elements after we replace them with the result. We only get 1 element, which is the result of the reduce function. So basically this is what reduce does. So instead of, we did this manually, but of course you can instead do it using the reduce function, and we see we get the same results. There are some caveats around what happens if the array has just one value. So there's probably, yeah. So actually there's a default argument. So in case there's a default argument passed here, the function f is called with something like default 1 in this case, because there are not enough elements to fill 2 of the arguments which f requires. To remind you, f is basically a function that sums to number. 2 plus 2 is 4, minus 1, that's 3. Quick maths. And basically when you have reduce without this default argument, it defaults to 0 in this case. So let's also check, just because I'm curious, what happens if the array is empty. Okay, so in this case we have to pass a default value and it gets returned. So perfect. So now basically what we want to do is count the correct nodes. Each correctly pressed node each success is marked as a 1 in the array, so we can just sum all the numbers to get the number of correct nodes, because zeros don't change the outcome. So let's do a reduce over this array, and we want to sum those elements. And to support the case where there is no elements, we also say that the default value is 0. Perfect. And hang on, I gotta take a sip of water. All right. So now here we can see the amount of correctly pressed nodes. And just to check, let's for now just return that. And see how it works. So hopefully today's streams, I mean, at least someone could get the idea of how reduce works, even though I am bad at explaining what I'm doing here with React and stuff. So there's some value, I hope. And this was supposed to be shown at all times. Oh, yeah. Do it like that. Yeah, so we have this accuracy function. Let's show the outcome for now. So let's say accuracy. Of course, this is not actually the accuracy for now, but Instead, this just tells us how many of the nodes were correct. And I forgot to close the curly brace. And of course, this is defined in the state here. And now it should work. Okay, so let's press the right node. This is F, so F, great, accuracy is 1. And if we press the incorrect node, the number of the correctly pressed keys does not increase. If we press, what is it, C# again, the number of correctly pressed nodes does increase. And now, after we make 100 mistakes, the accuracy should drop to 0, because this should only take into account the accuracy over the last 100 nodes. So let's try making 100 mistakes. Thankfully, I'm really good at making mistakes. That's basically what I do all the time. And there we go. The accuracy has dropped to 0 because we forgot about those other outcomes. Okay, so now to get a percentage, we can divide this by the length of that array. Wait, no. This happens when last 100 outcomes, when this array is empty. So we check for that, and if we do this, we have to return something. So we have to let's go with no data, because that's basically the truth. We have no data to calculate the accuracy. Wonderful. And now if we press the right key, so this is C, we get some information. And actually we have the accuracy. So now we can see that we have pressed, what, 20 keys or something. We made we have 2 correct key presses, 20 in total, so that's 10%. So actually we want to format this accuracy into percents. So we're gonna save this into a variable, and I think there's 2 fixed. Yes, basically we can say how many digits we want to have after the dot. So let's go with 1, and let's add a % sign after that. Oh, and of course we have to multiply the accuracy by 100 to get it in percents. So why is the accuracy not dropping? That is a good question. Let's try reloading the site, because it may have not been fully updated. So this is A. So is this A? Yes. So we have accuracy of 10%. So let's just verify. We pressed 1 node. Oh, I think I know what happens here. But let's just see. CD, E. Now let's press the E. Okay. Do we actually have 20% accuracy? I don't think that's the case, because we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 12 nodes. 2 12s is, of course, 16%. But actually what we did here using 2 fixed is, instead of using 1, okay, never mind, this should work. Why does it not work? Ah, now I see. What we do here, let me show you. So let's say we have the accuracy of, what was it, 2/12. So this is our accuracy. Now what we do with our code, we convert this to fixed point and then multiply it by 100. Of course, JavaScript doesn't show us any errors because it's JavaScript. It does not do that because that would be too helpful. So yeah, we have to, of course, multiply the accuracy by 100 before rounding it. And now we get beautiful information. What is this? F sharp. So this is F, this is sharp. And there we go. We have 4 mistakes, 1 correct one that gives us 20%. And it works beautifully. Now let's make 100 mistakes again to see if the accuracy drops to 0. As you can see, it steadily approaches 0, and after we cross the 100 mistakes threshold, it gets down to 0. Beautiful. So now we can show the accuracy over the last 100 numbers. So we're getting close to an hour of the stream. So we have like 4 minutes or 3 minutes to an hour. So we're gonna be finishing very soon, but let's have one more thing. As you can see, this n argument is ignored for now. But what we want to for it, sorry. It's been an hour of talking, I'm not used to it. We want this n argument to determine how many of the outcomes are taken into consideration in case you want to have some quicker changing accuracy stats. So let's do this. First, we're gonna have to do this. So we're gonna make sure this uses this array. And now what we can do is we can simply slice this array, this argument, to have only n elements. Oh yeah, I see what I did wrong. This is not the number of element, this is the end. And let me actually check. Yeah, okay, so I got it mistaken for the splice, which actually does take a count of elements to handle. Yeah, so we want the slice starting from 0 to 100. So, to 0 to n actually. So I would actually like to verify that it actually works the way we want. So let's try, because I'm not sure whether it would do 100 elements or, for example, 99. So let's say we want 3 elements. Yes, it works perfectly. Great. So, okay, so this is great. So now, before doing all of the calculations we did before, we also cut the array to have only n elements at most. So now what we can do is add some more information. So I broke something here. I'll just fix it. So this accuracy is gonna be over the last 100 outcomes. Then we're gonna have accuracy over the last 50 outcomes. And let's maybe add some line breaks to make it more readable. Oh, what happened here? 50, yes. And now let's do one over, let's say, 25 to have some quicker feedback. And it reformatted it, but whatever. And I have some, oh yeah, okay, not needed. And let's also add a, yep, okay, so let's try. We press a key, there's 0% accuracy, and let's make 100 mistakes. Okay, now we have 100 elements in the array. This is full, so let's press the correct note. That's gonna be A sharp. So, is this the one? Yes. So as you can see, over the last 100 notes, we get 1% accuracy because we pressed one note correctly out of 100 notes. 2% over 50, so this is correct. And now if we start making mistakes again, it does not work. Okay, the accuracy over 25 has already dropped to 0. Yes, it works perfectly. Now, after we reached another 50 mistakes, the accuracy here dropped to 0. And here we go. So let's try playing some correct notes again. See, the accuracy rises. What's that? Something up here. Oh. Perfect. Okay. So we have some basic accuracy stats. And yeah, this is gonna have to come on the next stream. So thank you for watching. And goodbye.